Hello, today I'm going to talk about a game which is on the internet and it is called the NAND game. So this game is a fun exercise to practice uh, your digital electronics course. So as it is written here, the NAND game inspired by building a computer from first principles, which is a book which is actually an MIT course. This game only covers a small part of the material in above course and it's a fun exercise. Yeah. So we should be very thankful to this guy. This guy has made a game out of that particular engineering course which actually helps us uh, visualize and imagine in a practical manner about the course. So what I'm saying is, even if we read the book, the course material, uh, it is still, it might be difficult to understand what actually is said in the book. So without applying the knowledge you gain from any book, unless you practice it by employing it practically, it is very difficult to achieve the desired result. So let's see what game he has made and go through this game if you like it and donate this guy. He has made a very good game, free of cost, available to everybody. Okay, so let's get back to the game. Let's go to the game and see what this game is about. So this game has many levels, and in the first unit, we are building a basic computer. So what is a computer? So computer is made up of computer has we all know that computer has a logical part because it can think logically. Like we can see the AI, it has its own logical thinking. So computer needs logic. Computer do mathematics and stuff. So it has arithmetic part. Computer can switch between tasks. So it should do that. So when we combine logic and arithmetics, it becomes ALU. Computer, we all know it can remember things. So it has a memory. So when you combine all of these units, it comes out to be a computer. Like when you all combine and assemble them. Sorry for the background noise. I do not have a noise cancellation. Okay. So the most important gates, like the logical parts, is AND, OR, and NOT. AND, OR, and invert. These three can be derived from NAND gate, and these three gates with different combinations will be able to handle any logical part, any logical problem which is thrown at the computer. These are the arithmetics. I will go in the arithmetics, and first let's go in the logical part. This is an OR gate built from an AND gate. When you give 1, when you give 0, it will become 1. When you give 1, it will become 0. Internal mechanics. This AND gate, both of them have to be true in order to get the desired result. OR gate, any one of them is true. it will give out true, otherwise false. And the addition is very interesting in this arithmetic section. This is called a half adder. So this is a truth table. When you're adding zeros, the sum should be 0 and there is no carry. When you're adding 0 and 1, it should be 1. Sorry, this is the carry. When you're adding two ones, it is like you're adding 9 and 1. When you add 9 and 1, it becomes 10. So this is it. Then you make a full adder out of it. Then there's a multi-bit adder, very important. You can construct an array of bits which can be added together. This is the switching part. This is again can be called as a logical part, because here if you give an input 1 or 0, whatever, depending on the input, it can choose what output to channel into this output. So what I'm saying is, if it's 0, this 0 will activate. If it's 1, this 1 will activate. So this is called a multiplexer. This is a demultiplexer. One input can be sent either of two outputs. This is the logical part. This is all the logics of the computer. The main idea what I'm saying is, like when we are reading and doing it practically, whatever doubts we have gets cleared because we are doing it. And also when we do it practically, we learn better, at least what I believe. So how does a memory is made up of? Memory has the basic component. This is a D latch. And then a data flip-flop is made out of it. Out of data flip-flop we make a register which can register a 16-bit or 8-bit whatever length of a data. Then we build RAM, which makes the memory part of the computer. So in the end, we see how we made a computer. This is the ROM, this is the memory of the computer, this is the control unit, this is the main brain of the computer, this is a counter, and this is a clock pulse. The clock pulse is nowhere explained very clearly, even in the engineering studies, what it actually is. Actually, these electronic circuits, every circuit has its own time of calculation. Suppose what I'm talking is, suppose this is electronic part. Because this part is bigger and this part is smaller, this part will take more time, this part will take less time. So when you combine in a particular amount of time, this is still calculating, but this has given its output. So when you assemble them, the answer will come out to be different because they are out of sync. So to sync them, we introduce a clock pulse. So in the clock pulse only, the output is calculated. So that's how I understood by practically doing it, which had cleared my long stayed doubt about the clock pulses. Even today, clock pulses are very complicated to understand. But when you play this game, it all becomes clear. So this is the brain of the computer. This is the memory. A and D are the immediate memory of the computer, and A naught is a larger part of the memory. You can store a lot of information there, but A and D can store only two 16-bit numbers, like a finite length of data in them. But they are very fast to access. They can be used and manipulated to uh, to calculate and compute many instructions. And here is a counter. This is the ROM. ROM is nothing but a program. ROM is nothing but a program. In this ROM resides a program, a set of instructions, and this counter, the work of the counter is to progress through all these instructions one by one, incrementing it. So it can jump also, like from in this instruction, if the computer is calculating in this instruction, and if the software demands that we jump to some other instruction, it can do that with the help of a counter. That's it. So building ROMs and programs is part of software engineering. Everything else is hardware engineering. When you play this game, it becomes very clear how a computer is made up of. This is a very good game, and this is the language machine understands. So we see that machine language, this is also called assembly language. So D is equal to D plus 1 J and E is nothing but, what it's saying is, in the destination D register, do D plus 1, and it is equal to Z. If it is negative, jump. Very easily understood and very easily understandable. And these are the codes. So these codes are given inside the ROM, and when it is connected to the computer, it computes and gives out desired result. And this is a multiplication circuit. We already seen how addition is done. This is a circuit which deals with which of the two numbers is greater. So the logic lies here. If you subtract two numbers, if it is negative, you can easily find out which is smaller or greater. And here, how did we see a number is equal to 0? A number is equal to 0 if all the bits are 0. So we put OR gates everywhere. Less than 0, like first we need to understand subtraction. If we play this game, it becomes very clear how does the science work behind it. There's a multiplication circuit. Multiplication is quite complex. Multiplication is nothing but, like when we say 2 times 5, it's nothing but add 2 to itself 5 times. Sorry, add 2 to 0 5 times. So 2 times 5 is to the 0 we add 2 5 times. So that logic we implementing and putting all the logic gates and addition circuits, we can multiply two positive numbers. Then we have floating point numbers, like which has decimal digits. Floating point addition, floating point multiplication. So all these units are definitely covered in the engineering courses, but simply reading them is not enough to get the idea behind it, because whenever we read sentences in the book, every sentence raises, every one sentence raises 10 doubts in our mind, and so we are always imagining, what did the author say, what did the writer say. So when you do it practically, you understand, your doubts clear, because whatever is said in the book, you understand it through practically, that the writer has said so and so, and which is true. Finally, as you play the game and level up, you will be making a multitasking CPU. This is the CPU which resides in our computer, everyday laptop and PCs. This is the hard disk. This is the brain of the computer called control unit. This is the registers and RAM. This is the clock pulse, and this is the mode changer. The mode changer is nothing but switching from operating system, that is kernel, to the main program. Like whenever we work on a computer, it consists of an operating system, right? In the operating system we install programs. So computer is constantly shifting between OS and different programs, and it does that with very high speeds. We never know that it is shifting between the OS and the computer programs, because it does that in very high speeds. So if we play this game, all the doubts about computer engineering and hardware engineering will go away. Very good game, recommended to those who are like studying hardware engineering courses. Very good game. And donate to this guy, because this guy has made this game free of cost, available to freely for anyone. Okay, so that was the video about it. Hope you like it. Thank you.